Hello everyone. So we have been talking about functions, and here is where we put it all together and just kind of connect all the different representations that we have. So there are 4 different ways to represent a function, and you can see them all kind of connected here over to the right. So the first way is a real world scenario. So in real life, right, we could say Takis cost $4 a bag. Our second way to represent that then is we could take that and we could put that into a table, right? So if I buy 1 bag of Takis, I'm spending $4. If I buy 2, I'm spending $8. And if I buy 3 bags, I'm spending $12. So you can start putting those numbers together in the table. From there, we can write an equation that talks about that, right? So if I want to take that and kind of make a shortcut where I can see no matter how many bags of Takis I buy, I can easily figure out the cost. I know that I'm going to be multiplying that 4 times the number of bags, right? So that rule, think way back to the first video, is going to be to multiply by 4. So I could represent this equation, y equals 4x. And the last way we've been working on a lot together is our graphs, right? So if I take all of those different costs and I put them together, I know that if I buy 0 Takis, that's $0. Again, 1 bag is $4, 2 bags is $8, 3 bags is $12. I can turn that into a graph, and you can see how that would make a perfect line if I wanted to graph it that way. So these are the 4 different ways to represent that same situation of Takis cost $4 per bag. There are 4 different ways to represent that function right there. The new thing for this video, right, is this real world scenario we're kind of adding in. So something that will help us as we're going through is if you look for those keywords each, every, or per. Those are usually going to tell us to be multiplying when we're talking about a word problem or a real life situation. And so those are going to be the numbers that are going to be associated with our x, which means they're going to be our slope or our rate of change. So you can see that that $4 per bag, right, means that my slope is 4, which again, my slope up 4 over 1, up 4 over 1. Same thing here, change in y over change in x is that 4 over 1. So all those things we've been talking about this whole unit are all coming together in this lesson. So the first thing we're going to do, though, is we're going to practice those new real-life scenarios. So let's look at number 1 together. So at Pizza World, each pizza costs $9.50. So if I'm looking at that, each pizza is $9.50, right? We want x to represent how many pizzas we're getting and y to represent the total cost. So again, our equation is always in the form y equals mx. And that each tells us that slope is 950. So my equation is y equals 950x. And we can also make sure this makes sense, right? If I buy 1 pizza, so if x is the number of pizzas, right? 950 times 1 gives me 950, so that makes sense of my total cost being y. All right, number 2, a pool is filled with water at a rate of 6 gallons per minute, and the table represents the relationship. So again, I could use my table to write my equation, but I'm seeing that per and that 6 together, right? So when I write my equation, y equals 6x. And again, we can check this by plugging in those numbers. So if I plug in 1 for x, 6 times 1 gives me 6. So this is working out. 6 times 2 gives me 12. 6 times 3 gives me 18. So it's following that table as well. All right, here's the last one where they're going to throw a little bit more of a trick at you. So we've got Marcus swims 10 laps in 15 minutes, and we want to write an equation to represent the number of laps y he can swim in minutes x. So for this one, right, we're going to have our y equals, but now we need to find that slope. So remember, our slope is always that change in y over change in x. So if I'm thinking about y over x, and my y is the number of laps that he can swim. Well, we said he could swim 10 laps. So I'm going to plug that in for y. My x, right, we said was our x minutes. So our 15 minutes. I'm going to get this fraction 10 over 15. And we know the rule, we always want to simplify. So I can divide both 10 and 15 by 5, which will give me 2/3. And so that becomes my slope to plug into my equation. So I get y equals 2/3 x. Now again, we can practice by, we can check this by plugging in our numbers. So if I say that he can swim x minutes, right? So if I plug in 2/3 times 15 minutes, I will get my y equals 10 for my 10 laps. So again, we're always looking at that y over x and just follow the labels as they are given. Okay. our last problem that we have then is number 4 over here. Jasmine opens a bank account and she deposits $5 each week. X is going to represent how many weeks that she has, and then our Y is going to represent the total amount in her account. So we want to figure out all the different situations that are going to represent that. So first things first, we said $5 each week, right? So that means we're looking for my slope being 5. So the first easiest way to see this is that equation y equals 5x. We know that matches up, right? Because I'm going to take each week times 5. So let's look at these tables then and see. So if x is my number of weeks, right? So after 1 week, she would have $5. 2 weeks, $10. 3 weeks, $15. So this table is also the one that matches our situation. We'll look at the other table here in a second. So this table is saying in 5 weeks, she would only have $1. In 10 weeks, she would have $2, and then in 15 weeks, she would have $3. So that doesn't make sense in our situation. So that is out. We also know that that equation is out, right, because we found our equation. So our last thing is to figure out which graph matches up. So one trick that you guys can know is because all of our situations are proportional, which means they always have to go through 0, 0. So right away, looking at this graph, the only one that goes through 0, 0 is going to be this one. So I know that this is my answer. But let's also talk about why this doesn't make sense for the problem. So we have our weeks down here and our total here. So this says 0 weeks, we have $0. That makes sense. 1 week, we have $5. Still good. 2 weeks, we have $10. That matches up exactly with our table and exactly with our situation. The other graph, though, is saying that at 0 weeks, she had $5. Then she had 6, 7, 8. So that is a different situation. So this one also does not match. Okay, to finish out this lesson and finish out this unit, we can be given any of the 4 things, right? So we can be given an equation, a scenario, a table, or a graph, and we should be able to fill in everything else based off of that. So we're going to practice some of these together. All right, so this first one, we have our equation, y equals negative 2x. So remember, this means that I'm taking whatever the x is and I'm multiplying it by negative 2 for that rule. So if I have negative 4 times negative 2 gives me positive 8. If I plug in 0, right, 2 times 0 gives me 0. 4 times negative 2 is negative 8, negative 16, and negative 24. So we can easily take that equation and turn it into the table just by multiplying out, following that rule that we talked about way back when. All right, now we can go ahead and graph. So remember that we can turn in these points into graphs, right? So I know I've got the point 0, 0. The only situation here is that none of these other points can be graphed. So if I have the point negative 4, 8, right, that is not going to fit on my graph. So we are just going to graph using our slope. So we know that our slope is negative 2. I know that I can always write that as a whole number over 1. So my rise is negative 2 and my run is 1. So again, using that rise over run, I'm going to make more points. I'm going to be going down 2 over 1, and I'm going to pause here and make the rest of my line. Okay, so we know how to graph given that equation or that table. So the last thing to add in is a scenario. So what is a scenario where we'd be multiplying by negative 2 for each thing? Well, if we have a negative 2, right, it's kind of like we're losing something or something's being subtracted. So I like to think about money. So we'll say that we're spending $2 every week. And there we go. We took one little equation and we turned it into a table, a graph, and a real-world scenario. So let's go ahead and try the next one out. So for number 2, this time they gave us a table. So from that table, right, again, we can go and see if we can graph this right away. So I know I've got the point 0, 0. All right, and this time I do have some points I can graph. So I've got negative 2, negative 5. And positive 2, positive 5. So I can see that those make my line. Probably the easiest way to go from a table to that graph is by just making these into those ordered pairs x, comma, y. So whenever you can, right, we want to graph those as easy as we can. All right, so we've got the table, we've got the graph. Now we need to come up with an equation. So I have y equals, and I just need to find my slope. So we can find the slope from the graph or the table. We practiced both of them. So let's go from the table first. So my change in y, we are adding 5. My change in x, we are adding 2. So I would write that as 5 over 2 x. Change in y over change in x. We can also check that with the graph, right? So starting from our point, we know that means my rise should be 5 and my run should be 2, which again matches up. So everything is coming together. All right, let's talk a real world scenario, right? Okay, so let's say that we have a bucket of fruit or fruit basket, and we need to put in a certain number for each thing. So let's say that we have 5 oranges for every 2 apples. The last thing we want to do is make sure we say what is our x and what is our y so it matches our scenario. So remember that we always have our y over x for our slope. And so that means that that 5 has to be connected with our y. So we're going to say that y is our oranges and that x is our apples. So again, that 5 is associated with my y, 5 oranges. That 2 is associated with my x, 2 apples for our x. All right, we have one last scenario to go through. So here we go. This time they gave us the graph to start off with. So when we have a graph, we can turn this into a table really easily just by plotting those ordered pairs. So let's start left to right. So this point is at negative 1, 2, 3, 4, and then down 1, 2, 3, 4, 5, 6. So that's the point, negative 4, negative 6. Then we've got negative 2, negative 3, 0, 0 in the middle, 2, 3, and 4, 6. All right, we know we can also write an equation really easily from a graph by finding that slope. So again, if I'm looking at rise over run, I'm going up 3 over 2. So my slope is 3 over 2. So my equation would be y equals 3 over 2 x. And the last thing for a scenario, again, I just need something where I have 3 of something for 2 of every of something else. So let's say maybe in a math class, we have 3 boys for every 2 girls. Okay, and so remember we always have our y over x, so whatever we have associated with that y number, which in this case is our boys, needs to be our y. So this time we'll have our boys, our y, and our x is for our girls. All right, and again, so we have looked at every situation where we can be given either an equation, a table, or a graph, and we can fill in everything else from there. And now we also know how to connect that to our scenarios. So I hope you have enjoyed our functions unit, and I will see you next time. Have a great day.